So what is this significant figures? Significant figures, it is a signified way of measuring the values. Density is equal to mass by volume. Multiplication or division, the final result must retain as many significant figures as in case of original values. Hello everyone, I am Brinda, Faculty of Physics, Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 5 of chapter 2, that is Units and Measurements. So today's class, let us discuss about the significant figures. So what is this significant figures? Significant figures, it is a signified way of measuring the values. So each and everywhere you just see the measurement, right? Arithmetic operations, it might be addition, subtraction, multiplication or division. You just observe the number of digits there, decimal point and few number of digits. But have you ever heard of rounding up the digits? Yes, you have heard. Instead of writing 0.12 numbers or infinite numbers, we just round off the number, approximate. We just say approximately so and so numbers, right? How much of grams are present in that sack? You just give an approximate measurement, right? That is where you use the significant figures. So results obtained due to the measurements, it includes digit which is known as reliably and the first digit that is uncertain. I'll tell you what is reliably and first digit that is uncertain. That is reliably plus uncertain. The first digit that is uncertain. These together it is known as significant figures. It is known as significant figures or significant digits. Okay, so the result, it is given an approximation. That approximation is based on this significant figures. There is reliably digits as well as there is uncertain digits. Together it gives you the significant figures. So now the rules to undergo, how exactly the significant figures is taken up. How you just approximate the numbers, digits or the measured values. So the rules are, here are the list of the rules. When you read it randomly, you may not be able to know how exactly it goes. So I'm here to explain you regarding the rules of the significant figures. All non-zero digits are significant. All non-zero digits, the number which are not zero. For example, you can just take it as 2345. This is just a number what I'm taking. So 2345. So all non-zero digits are significant. Okay, so these are non-zero digits. It doesn't contain any of the zeros in those four places. So all non-zero digits are significant. And one rule you got to know. It's easy, no? So let us go to the next rule, that is all zeros between non-zero digits are significant. All zeros between non-zero digits are significant no matter where the decimal point lies. Okay, so for example, I can take an example as 1009. I'm just taking a random numbers for you people to understand. So the second rule says that all zeros between non-zero numbers are significant. So you can tell how many significant figures are there? There are 4 significant digits. Okay, so here also there are 4 significant digits. You have to give number of significant digits there. So you have understood the first rule. So the second rule is also understandable. If the number is less than 1, to the left of the first non-zero digit are not significant. To the left of the first non-zero digit. Okay, so for example, you can just consider, what is the rule? If number is less than 1, okay, number is less than 1, it is 0 or in terms of minus, but here we are just considering in terms of zeros. Okay, less than 1 is nothing but 0. Okay, if number is less than 1, to the left of the first non-zero digit, to the left of the digit, it is not to our left hand side, they have mentioned to the left of the first non-zero digit are not significant. So if it is 2000, the number is 2000. So if number is less than 1, that is zeros, to the left of the first non-zero digit are not significant. To the left, this is the left of the non-zero digit and this is the right of the non-zero digit. So towards the left of the non-zero digit is, you have got 3 zeros. So those 3 zeros are not significant. They are not significant. Okay, so I hope you understood the 3 rules. Okay, that is, first rule says that all non-zero digits are significant and the zeros between non-zero digits are significant, and the zeros towards the left hand side of the digit, towards the left side of the digit, okay, that is non-zero digit, is not significant. I hope you're clear with all 3 rules. Let us go to the next rule, that is, the terminal or a trailing zero in a number without a decimal point are not significant. The ending zeros, that is the same as this rule. Okay, so the terminal or a trailing zero in a number without a decimal are not significant. And even in case of decimal place that you have got, if you are having an example of 0.002308, here you can tell, the rules tells that the decimal place is present here, the 0 before the decimal place, that is towards the right as well as towards the left, before this non-zero number starts, that is 0.00, these are not significant. Not significant number. So what remains is 2308. How many significant number is there? There are 4 significant number. Yes, of course, this 0 is also significant. Why? Because as the second rule tells that the zeros between non-zero digits are significant. The 0 between non-zero digits are significant. So there ends your decimal place. Next, decimal place rules. Next is the trailing zeros in a number with a decimal point. The trailing zeros, that is the ending zeros, in a number with a decimal point are known as significant. If, for example, 3.500, if this is the number, then you can tell that according to this rule, trailing zeros in a number with a decimal point are significant. Decimal point is there, the trailing zeros are there. So these all are significant. So how many significant figures are there? There are 4 significant figures. So I can write there are 4 significant figures. Okay, so the last rule, that is, there are certain confusions. Yes, there are certain confusions regarding the trailing zeros, okay, in a number with no decimals, which can be cleared by using a power rule. How is that power rule takes place? That is, you all have heard that is into 10 raised to some power, into 10 raised to 1, into 10 raised to 2, into 10 raised to 3, all those, okay, that is a power rule. So, if for an example, you have got 4.700 meters. If you have got 4.700 meters is a value of some length, you are measuring some length and the measurement of the length is 4.700 meters. When you convert into centimeters, it becomes 4.70 centimeters. And when you convert it to millimeters, it becomes 4700. It is 4700 millimeters. And again, when you convert it to kilometers, it becomes 0.004700 kilometers. This is how it becomes. So, what you're supposed to do? 4.700, same number, but with different units, it has got different significant figures, wherein we don't know how exactly it goes, but we have to, these are all one measurement of a one question. This is a measurement of some one measured value. So, but there are certain differences, that is because of the SI units. Because of its unit, the unit doesn't play any role in the significant figures. Units may change, but significant figures never change. So for this, what are we supposed to do? That is, we are introducing a rule called as power rule, so that the significant remains one and the same. Only the powers are considered to be not significant. They are not significant figures. So how will you change all these to a power rule? That is, instead of 4.700 meters is converted, this is a main value, measured value for us. This has to be converted into centimeters, millimeters and kilometers. If I have to convert it to centimeters, I will introduce 4.700 into centimeter is always 10 to the power 2. Okay, so it is 10 raised to 2 meters. Okay, so again, if I have to, so centimeter is done. If I have to convert it to millimeters, it will be 4.00 into 10 raised to 3 meters. So that is millimeters. Again, if I have to convert it to kilometer, it will be 4.700 into 10 raised to minus 3 meters. So this is centimeter, millimeter and 10 raised to minus 3 is known as kilo. So it is kilometers. So the main figure has remained constant, that is 4.700, again 4.700. So how many significant figures are there? There are 4 significant figures. 4.700, 3.500, that is one and the same according to the last but second rule, that is the trailing zeros in a number with a decimal point they are significant. So these numbers are significant. So there are 4 significant numbers, out of which we are excluding 10 raised to 2, 10 raised to 3 and 10 raised to minus 3. Wherein 10 raised to 2 determines your centimeter, 10 raised to 3 determines your millimeter, 10 raised to minus 3 determines your kilometer. Okay, so next, having these set of rules in our mind, we got to know how the significant figures are branched, how exactly you can measure the values and approximate it. There are certain few more rules when it comes to the arithmetic operations. So now what are these arithmetic operations? The arithmetic operations are maybe addition, subtraction, multiplication or division. So you all have studied, you all know the addition, subtraction, multiplication and division, which are known as arithmetic operations. But do you all know how exactly to approximate the value, where exactly you have to stop and where not to stop, which has to be written in the value, which has to be excluded in the value? Many of you have heard from your teachers that they have taught you, you have to right up till 3 decimal places, right up till 2 decimal places when you show them your results, right? So let us see how exactly the rule goes. Arithmetic operations with the significant figures. See, the significant is like a leech. It has stuck to your each and every operation. So throughout, it is stuck as a leech itself throughout the arithmetic operations or numericals or any such measurements. Okay, so the rule says that the result what you get, it shouldn't have more significant figures than the original measured value. It shouldn't have more significant figures than the original measured value. That is the actual thing you have to understand. That is, the result what you get, it shouldn't contain more numbers, more significant figures than the original values or the values which are present in the question. So this is a general rule what is being told here. So for example, I have taken the mass of the object is 4.327 grams and the volume is 2.51 centimeter cube. So we have to find the density of the object. So now you will have to find the density. So what is the formula for the density? It is density is equal to mass by volume. Density is equal to mass by volume. This is the formula for density. So what is mass? Mass is nothing but 4.327 grams. 4.327 grams. Okay, so what is the value? It is 2.51 centimeter cube. So volume 2.51 centimeter cube. On dividing 4.327 divided by 2.51, we get 1.72390 gram per centimeter cube. Okay, gram per centimeter cube. Do you really think you can write like this? But what does the rule says? The final result shouldn't have more significant numbers or figures than the originally measured values. So what is the original measured values? 4.327 grams. The other one is 4.51 grams centimeter cube. So when it is 4.51 centimeter cube, which is the least value what is there? Out of these two, the least value is 2.51. So there are how many significant figures? 3 significant figures. So round off this result to 3 significant figures, that is 1, 2, 3. 1.72. Okay, so I can write it as my final result is 1.72 grams per centimeter cube. So this is how it goes. So this is a generally which is being told for arithmetic, that is either addition, subtraction, multiplication, division. According to set of rules, it is told that in multiplication or division, the final result must retain as many significant figures as in case of original values. That is, the result, this side, consider this side, it consists of original values and it is result. So when you are getting the result, how you are supposed to put up the result? That is by looking at the original values and check which value is having least significant figures. That significant digits, how many significant numbers are there? Those many has to be in result. Okay, it all depends upon the least significant figured value, the value which has got least significant figures, that is being matched with the result whatever you get in case of multiplication and division. In case of addition and subtraction, the rule says the final result should retain as many decimal places as in the case of least original value. Okay, it should contain the final, that is, it means it is a final result. The final result should retain as many decimal places as in the number with the least decimal places. Okay, so that is in case of addition and subtraction. Having these set of rules, let us just round off certain numbers, that is certain value which is present there. Let us round off the numbers. Now let us go to the rounding up of the significant figures. So in order to round up the significant figures, what are you supposed to do? That is, you have got certain set of rules and regulations. So let us round off these by using rules and regulations, that is 2.746. They have asked you to round up, that is approximate. Round up for 3 significant digits. So how it goes? 2.746. You need only 3 significant figures. So it is 1, it is 2 and it is 3. You just need 3 significant figures. So you have to round it up. Okay, can you just write it as 2.74? No. According to the rule, the succeeding, number 6 is a succeeding one and the previous number is always known as preceding term. Preceding number, succeeding number. Okay, so the 6 is a succeeding number. So just check out the preceding number. What is that? It is 4. So 6, is it greater than 5? Yes, 6 is greater than 5. So when 6 is greater than 5, the preceding term should be raised by 1. Okay, so here we have to raise preceding term is raised by 1. That is plus 1. Preceding term plus 1. So what is the value you are getting? 2.75. Instead of 4, I am writing 5 because the succeeding number, that is 6, is greater than 5. That is why I am putting plus 1. I am replacing 4 by 5. That is adding up the preceding term by 1. Okay. So how will you go with the second one? That is 2.743. Again, you have to round up the figure to 3 significant figures. Since 3 is less than 5, here you are considering 6. No, likewise, here we are considering 3. So again, 5 is the standard number which we are considering while rounding off. So the standard number, the 3 is lesser than the standard number. What is the standard number which we are considering? It is 5. So 3 is lesser than 5. So the preceding term remains as it is. Preceding term remains as it is. There is no plus or no minus. So preceding term remains the same. So what is the value? It is 2.74 is the value. Again, you have the third one, that is 2.745. Now you have been caught hold of. That is again 3 significant figures, 2, 1, 2, 7 and 4. That is 1, 2, 3 significant figures. And which number are you checking? After the 3 significant figures, there is one number. That one you will be checking out. So that is equal to standard number. So when it is exactly 5, what can you do? So when it is exactly 5, there is again other set of rules. That is, when it is 5, there are 2 points. The preceding term when your preceding term is even, when the preceding term is even, there is no change. No change in the number. Okay, when preceding term is even, there is no change in number. When preceding term is odd, when preceding term is odd, it is raised by 1. No change. And it is raised by 1 when it is odd. Okay. So that rule is applied to the third one, that is 2.745, whereas 2.7 and next number that you will have to put what exactly it is according to this rule. And 5 is there. So 5 is a standard one. You have got 5. You are stuck between 2. So you have to check whether this preceding term 4, it is even or it is odd. It is even. Because it is even, you can just take it as 2.74. There is no change. It is even, the preceding term even, so there is no change. Suppose if it was the question, fourth question is 2.715, then your answer should have been like, since you have got 3 decimal places and 5th is the number which is standard and it is in between, so what are we supposed to do? It is preceding term is odd, so you have to raise it by 1. So you have got 2.7, instead of 1 it will be 2.72. This is how you go on with the rounding of the digits. So I hope, so in today's class we have discussed about the significant figures as well as how do you go with the set of rules that is used to approximate the numbers. I hope you're clear with the things whatever we have studied today, and it was informative for all of you. So thank you one and all. Let's meet in the next session. Have a good day.